Sandboxing is a technique used in cybersecurity to analyze potentially malicious files, applications, or websites in a controlled and isolated environment. It creates a virtual environment or a simulated operating system where these potentially harmful elements can be executed and observed without affecting the actual system or network. The main purpose of sandboxing is to detect and prevent threats by allowing security researchers, analysts, or automated systems to study the behavior of suspicious files or software safely. By isolating these potentially dangerous elements, sandboxing minimizes the risk of infection or damage to the host system. Here's how sandboxing typically works. Isolation. Sandboxing creates a separate environment, often a virtual machine, VM, or a container, with its own resources, such as CPU, memory, and storage. This isolation ensures that any malicious activity is contained within the sandbox and does not spread to the host system. Execution and monitoring. The suspicious file or application is executed within the sandboxed environment. As it runs, various activities are monitored, including system calls, network traffic, file system changes, and behavior patterns. This monitoring allows security analysts to observe the actions of the file or application and identify any malicious behavior. Analysis and detection. The behavior and actions observed within the sandbox are analyzed to determine if they are malicious or pose a security risk. This analysis may involve comparing the observed behavior with known signatures of malware or using machine learning algorithms to identify patterns of malicious activity. Reporting and response. Based on the analysis results, a report is generated to provide information about the nature of the threat. If the file or application is determined to be malicious, appropriate actions can be taken, such as blocking or quarantining the file, updating security measures, or developing new detection signatures. Sandboxing is an effective approach for detecting and analyzing new or unknown threats, as it allows security experts to study their behavior and develop countermeasures. It helps in identifying malware, zero-day exploits, and other sophisticated attacks that may evade traditional security measures. Sandboxing is commonly used by security vendors, researchers, and organizations to enhance their threat detection and response capabilities. It's worth noting that while sandboxing provides a valuable layer of security, it is not foolproof. Sophisticated attackers may employ techniques to detect the sandbox environment and modify their behavior accordingly. Therefore, sandboxing is often used in conjunction with other security measures, such as antivirus software, intrusion detection systems, and network monitoring, to provide comprehensive protection against cyber threats. There are different types of sandboxing techniques used in cybersecurity, each with its own approach to isolating and analyzing potentially malicious files or applications. Here are some common types of sandboxes. Operating system level sandboxing. This type of sandboxing utilizes the built-in security features of an operating system to create an isolated environment. For example, on Windows, the Windows Sandbox feature creates a lightweight virtual machine, VM, where untrusted applications can be executed and monitored. Virtual machine sandboxing. In this approach, a complete virtual machine is created using virtualization software such as VMware or VirtualBox. The sandboxed environment is separate from the host operating system, providing a high level of isolation. Security researchers often use virtual machine sandboxes to analyze malware samples and study their behavior. Containerization. Containers are lightweight, isolated environments that share the host operating system's kernel. Technologies like Docker or Kubernetes enable the creation of sandboxed containers for running applications or services. Container sandboxes offer fast deployment, scalability, and isolation, making them popular for testing and deploying software securely. Web browser sandboxing. Web browsers employ sandboxing techniques to isolate web content and plugins, minimizing the impact of malicious websites or browser vulnerabilities. Examples include Google Chrome's sandboxed architecture, using techniques like process isolation and sandboxed plugins, and Microsoft Edge's Application Guard, which runs potentially untrusted websites in an isolated container. Network sandboxing. This type of sandboxing focuses on analyzing network traffic and monitoring potential threats. Network sandboxes intercept incoming and outgoing network communications, examining them for malicious patterns or behaviors. These sandboxes can analyze email attachments, URLs, and other network-based threats. Cisco's Advanced Malware Protection (AMP) and FireEye's malware analysis are examples of network sandboxing solutions. Mobile app sandboxing. Mobile operating systems, such as iOS and Android, implement sandboxing mechanisms to isolate apps from each other and the underlying system. Each app runs in its own sandbox, preventing it from accessing or modifying data belonging to other apps. This approach enhances the security and privacy of mobile devices. These are just a few examples of sandboxing techniques used in cybersecurity. The choice of sandboxing method depends on the specific use case, level of isolation required, and the resources available. Often, a combination of sandboxing approaches is used to provide layered protection against various types of threats. Thanks for watching. Kindly subscribe the channel for more such videos.